Imagine a powerful technology invented long ago. It was clever and full of promise, but then a newer, flashier invention came along and stole the spotlight. The older technology was almost forgotten, like a dusty toy in the attic. This is the story of the zinc bromine battery. It's an amazing energy storage solution that was first thought of way back in the 1800s. For a long time, it sat on the sidelines of science. Now, as we search for better ways to power our world with clean energy, this old idea is making a huge comeback. It's ready to show us what it can do. Think about all the gadgets we use every day. Our phones, our laptops, and even our cars are powered by batteries. These batteries are incredible, letting us carry energy around in our pockets. But the story of energy is much bigger than just our personal devices. We need giant batteries to store power from the sun and the wind. This is called grid-scale energy storage. It's a huge challenge. We need batteries that are safe, cheap, and can last for a very long time. The batteries we use today have some problems. This is where our forgotten hero, the zinc bromine battery, re-enters the story with a new purpose. The journey of the zinc bromine battery is a fantastic example of how science works. Sometimes an idea is ahead of its time. The world might not be ready for it, or another technology might seem better at that moment. But good ideas don't just disappear. They wait for the right problem to solve. The zinc bromine battery waited patiently while the world fell in love with a different kind of battery. Now, the challenges of our modern world, like climate change and the need for a stable power grid, are creating the perfect moment for this old technology to shine once again, stronger and more relevant than ever before. So, let's get ready to explore this amazing comeback story. We will uncover the secrets of this fascinating battery. We will see why it was overlooked and why it is now so important. This isn't just a story about chemicals and electricity. It's a story about innovation, about looking to the past to build a better future. It's about how a simple, robust, and clever design could be one of the keys to unlocking a world powered by clean, renewable energy for everyone. The unsung hero is finally ready for its moment in the spotlight. If you own a smartphone, a laptop, or an electric car, you are using a lithium-ion battery. These batteries are everywhere. They became popular because they are incredibly good at what they do. They can pack a lot of energy into a very small and lightweight package. This is called high energy density. It's the reason your phone can be so thin and still last all day. When lithium-ion batteries first arrived, they were a revolution. They made portable electronics possible and are now powering the electric vehicle boom. They are the undisputed king of modern batteries, but even kings have their weaknesses. The success of lithium-ion batteries has come with a price. The materials needed to make them, like lithium and cobalt, are becoming more expensive. Mining these materials can be very harmful to the environment. It uses a lot of water and can release toxic chemicals into the ground. Also, much of the world's cobalt comes from places with unsafe working conditions and political instability. This makes the supply chain fragile and raises serious ethical questions about where our battery materials are coming from. The cost and environmental impact are big cracks in lithium's shiny crown. Another serious concern is safety. You may have heard stories about phones or laptops catching fire. This is often because the lithium-ion battery inside them has failed. The liquid inside these batteries, called the electrolyte, is highly flammable. If the battery gets damaged or overheats, it can lead to a dangerous situation called thermal runaway. This is like a fire that feeds itself and is very difficult to put out. As we start building bigger and bigger battery packs for our homes and power grids, this fire risk becomes a much more serious problem we need to solve. So while we should thank lithium-ion batteries for the amazing technology they have given us, we also need to be honest about their limitations. They are fantastic for small, portable devices where size and weight are the most important things. But for the massive energy storage we need for a green power grid, their high-cost environmental footprint and safety risks are major hurdles. This is why scientists and engineers are looking for alternatives. They are searching for a new hero for a different kind of job, a job that requires a battery that is safe, cheap, and sustainable. So how does this forgotten battery actually work? Let's break it down. The zinc bromine battery is a type of flow battery. The name sounds complicated, but the idea is wonderfully simple. Imagine you have two separate tanks of liquid. In a zinc bromine battery, these tanks hold special liquids called electrolytes. One liquid has zinc particles in it, and the other has bromine. To charge the battery, you pump these two liquids past a special membrane. As they flow, a chemical reaction happens. Metallic zinc plates onto one side of the membrane, storing energy like a compressed spring. When you want to use the energy, you just let the process happen in reverse. The plated zinc dissolves back into its liquid, releasing the stored energy as electricity. The liquids then flow back to their tanks, ready to be charged up again. The key thing to understand is that the energy is stored in the liquids in the external tanks, not inside the battery cell itself. This is very different from a regular battery, where all the energy-storing materials are sealed inside a small can. This simple design is what gives the zinc bromine battery its most amazing superpowers. One of the coolest things about this design is that the battery's power and its energy capacity are separate. The power, how much electricity it can provide at one moment, depends on the size of the central part, the membrane stack. But the energy capacity, how long it can provide that power, depends only on the size of the tanks holding the liquids. If you want the battery to last twice as long, you don't need a whole new battery. You just need bigger tanks. This makes the system incredibly flexible and easy to scale up for huge energy storage projects. This flow design also explains why these batteries can last so long. In a normal battery, the chemical parts that store energy break down a little bit every time you charge and discharge it. Over time, the battery wears out. But in a zinc bromine battery, the liquids are constantly refreshed. The chemical action is gentle and fully reversible. This means the battery doesn't degrade in the same way. It can be fully charged and fully emptied thousands and thousands of times without losing its ability to hold a full charge, making it a true workhorse for long-term energy storage. The first and most important advantage of zinc bromine batteries is safety. Remember the flammable liquid inside lithium-ion batteries? Zinc bromine batteries are completely different. The electrolytes are mostly water. This means they are not flammable. You can't set them on fire. This is a massive advantage, especially when we think about putting large battery systems in neighborhoods, commercial buildings, or next to valuable power plants. The inherent safety of the chemistry means we don't have to spend as much money on complex and expensive fire suppression systems. It gives everyone peace of mind. Next, let's talk about cost. The main ingredients for a zinc bromine battery are zinc and bromine. These materials are abundant all over the world and are much cheaper than lithium and cobalt. Zinc is a common metal used to coat steel to prevent rust, and bromine is extracted from seawater. Because these materials are so common and inexpensive, the overall cost of building a large zinc bromine battery system can be much lower than a lithium-ion system of the same size. For projects that need to store huge amounts of energy for many hours, this low cost makes a world of difference. Another superpower is endurance, or what scientists call a long cycle life. A key feature of zinc bromine batteries is their ability to be discharged completely to 0% without being damaged. You can use every last drop of stored energy. This is a big no-no for lithium-ion batteries, which can be permanently damaged if you drain them too much. Because the zinc bromine battery can handle this deep cycling over and over again for many years, it offers a more robust and reliable performance. It's built to last, making it a very smart long-term investment for grid-scale storage. Finally, these batteries are highly efficient and don't mind the heat. They can operate well in a wide range of temperatures without needing expensive and energy-hungry cooling systems. This is particularly important for installations in hot climates like deserts where we have lots of solar farms. The combination of being safe, low-cost, long-lasting, and able to handle tough conditions makes the zinc bromine battery almost perfectly designed for the job of storing renewable energy on a massive scale. It's a solution that addresses the biggest weaknesses of the current battery king. An old idea is only as good as the new ways we find to use it. For years, zinc bromine batteries had a few challenges that held them back. Early designs could be complex and they sometimes suffered from problems like dendrites, these tiny zinc spikes that could grow and damage the battery's membrane. But today, a new generation of clever companies and brilliant scientists are solving these old problems with fresh thinking and modern technology. They are taking the core, powerful idea of zinc bromine chemistry and re-engineering it for the 21st century, making it more efficient, reliable, and practical than ever before. These innovators are not just making small improvements, they are completely rethinking how these batteries are built and used. They are developing new materials for the membranes, creating smarter computer control systems to manage the flow of the electrolytes, and designing modular battery units that can be easily stacked together like building blocks. This modular approach allows them to build energy storage systems of almost any size, from a system that can power a single home to one that can support an entire town. They are turning a promising laboratory concept into a real-world commercial product. Two of the most exciting companies leading this charge are Redflow from Australia and Lithium-Ion, a company spun out of the University of Sydney. Each company has taken a unique approach to perfecting the zinc bromine battery. They are not competitors in a traditional sense, but rather pioneers pushing the boundaries of what this technology can do. Their work is proving that zinc bromine is no longer just a theoretical alternative to lithium-ion. It is a market-ready solution that is being deployed right now in real projects around the globe, providing clean and reliable power. The success of these companies is sending a powerful message to the energy industry. It shows that there isn't just one single solution to our energy storage needs. Different applications require different types of batteries. While lithium-ion is great for your phone, zinc bromine is emerging as a champion for long-duration storage. These innovators are creating a more diverse and resilient energy landscape, where we can choose the right tool for the right job. Their work is the crucial step that connects the battery's amazing potential with our world's urgent needs. Let's take a closer look at one of these innovators, Redflow. This Australian company has become a world leader in manufacturing zinc bromine flow batteries. They didn't invent the basic chemistry, but they have perfected the engineering to make it a robust and commercially viable product. Their main product is a standardized battery module about the size of a small refrigerator. These modules can be connected together to create systems of varying sizes. This plug-and-play approach makes installation much easier and faster for customers. Redflow's batteries are designed to be tough. They are built to withstand the harsh conditions of the Australian outback, which means they can work almost anywhere. They are being used in a wide variety of places. For example, they are helping remote communities and off-grid farms reduce their reliance on noisy, polluting diesel generators. They store solar energy during the day and provide clean, silent power through the night. In California, Redflow batteries have been installed to help businesses manage high electricity costs and provide backup power during grid outages and wildfires. One of the cleverest things about Redflow's design is how it manages the battery's health. The battery's control system can periodically run a special maintenance cycle. During this cycle, it completely drains the battery and resets the internal components, stripping away any zinc deposits that might have formed incorrectly. This is like a spa day for the battery, and it's a key reason why their systems can maintain their full energy storage capacity for over a decade. It's a smart solution to one of the technology's historical challenges, ensuring a long and productive life. Redflow's success demonstrates the perfect niche for zinc bromine flow batteries. They are being used in telecommunications towers to ensure reliable mobile phone service, in industrial facilities for peak shaving, storing cheap energy at night to use during expensive daytime hours, and in large-scale solar and wind projects. The company has proven that zinc bromine technology is not just a future promise. It is a practical, powerful tool that is already helping to build a more sustainable and resilient energy infrastructure today, one modular battery at a time. Now let's look at a different, equally exciting approach from another innovator, Lithium-Ion. While Redflow perfected the traditional flow battery design with pumps and tanks, Lithium-Ion decided to change the form of the battery itself. They developed a unique zinc bromine gel. By turning the liquid electrolyte into a thick, gooey gel, they were able to get rid of the need for all the pumps and plumbing. This makes the battery simpler, cheaper, and safer. It also opens up a whole new world of possibilities for where and how these batteries can be used. Lithium-Ion's Endure battery is a non-flow battery. This means all the chemistry happens inside a single sealed unit, more like a traditional battery. However, it still uses the safe, low-cost zinc bromine chemistry. The gel is the secret sauce. It stops the bromine from moving around too much and causing problems, which was a challenge in older designs. This innovation makes the battery more stable and allows it to be used in more flexible shapes and sizes. It's a brilliant twist on the original zinc bromine concept, combining the best of both worlds. One of the most amazing applications for Lithium-Ion's technology is in what they call smart solar farms. They are designing solar panels that have their gel battery technology built directly into the panel's support structure. Imagine a solar panel that not only generates electricity, but also stores it right on the spot. This would completely eliminate the need for separate, centralized battery buildings. It would make solar power cheaper, easier to install, and more efficient. It is a truly integrated solution that could revolutionize the way we build renewable energy projects. Jellian's story is a perfect example of how innovation can come from looking at a problem from a completely new angle. By turning a liquid into a gel, they solved several key challenges at once and created a product that is different from anything else on the market. Their focus on integrating batteries directly into infrastructure like solar panel mounts is a glimpse into the future of energy. It shows a world where energy storage isn't just in a big box in the corner, but is woven into the very fabric of our energy systems, making clean power available everywhere, for everyone. The story of the zinc bromine battery is more than just a tale of two liquids in a tank. It is a powerful lesson in innovation. It teaches us that sometimes the best solutions for the future can be found by looking into the past. An idea that was born in the era of steam engines is now being reimagined to solve the challenges of the 21st century's clean energy transition. It reminds us that progress isn't always about inventing something brand new. Sometimes, it's about seeing an old idea with fresh eyes and applying new knowledge to unlock its true potential. It's important to be clear. Zinc bromine batteries will not replace lithium-ion batteries everywhere. Your next smartphone will almost certainly still have a lithium-ion battery, and that's okay. The goal isn't to find one battery to rule them all. The goal is to build a diverse family of energy storage technologies, each with its own special talents. Lithium-ion will continue to dominate in applications where lightweight and small size are critical. But for the massive stationary energy storage that our power grids desperately need, zinc bromine is poised to become a true champion. As we build a world powered by the sun and the wind, we will need more than just panels and turbines. We will need vast reserves of energy storage. We need batteries that are safe enough to place in our communities, cheap enough to deploy on a massive scale, and durable enough to last for decades. The zinc bromine battery, in both its flow and gel forms, checks all of these boxes. It is the missing piece of the puzzle, the technology that can store the sun's energy to power our homes long after the sun has set. So the next time you hear about the future of energy, remember the story of the forgotten battery. Remember that the path to a cleaner, brighter future is being paved not just by brand new discoveries, but by the rediscovery of powerful ideas. Innovators like Redflow and Jellian are showing us that with a little bit of ingenuity, we can teach old technologies new tricks. The zinc bromine battery, the unsung hero of energy storage, has been waiting patiently for its moment. And now, its time has finally come.